Hello dear students, let's return again to Pumping Lemma, and this is our fourth video on Pumping Lemma. Just see, I have returned to the previous problem that we solved in the earlier video. I'm still with example 2, and we proved that this language is not regular using Pumping Lemma. A raised to n, b raised to 2n is not regular, but we proved it using Pumping Lemma. Let's use some intuition over here. Intuition. Without using Pumping Lemma, can we have a foresight? Can we just guess that this language is not going to be regular? Now this is a trial and error method which should not be used, in fact, because intuitions are very dangerous. But then still, straight away when you see this language, you would say it is impossible to build a DFA for this. The question is why? Why is DFA not possible for this problem? Let's try to figure out. What we have is, in the leading there should be n number of A's, and in the lagging there should be exactly double the number of A's. B should be double the number of A's. So what is the kind of DFA that we will build? See, if we say that in the initial state Q0 there should be A as the leader, we can't have B as the leader. So if we get first letter B, if we get the very first letter B, in that case we will send the machine to dead state. So it's final that if somebody gives the input as B A, then this is of the form B raised to 1 A square. But then we don't want such strings. We want A square B is allowed, or A square B raised to 4 is allowed, where B should be double the number of A. The leader cannot be B. If the first letter read is B, then we simply send it to dead state. And what if the first letter is A? Okay, acceptable. We can send it to Q1. So just check that if the very first letter is A, then this A might be followed by many more A's because it is A raised to n. Now here is all the crux of this DFA. We are saying that after the first A, there can be 0 or more A's. Please try to understand, this loop is 0 or more A's. And then we may say this A is followed by B and more number of B's, and then ends this DFA with final state. But if this, after this n number of B's, after this arbitrary number of B's, if we get any more A's and B's, then we should send the machine to dead state. Are you sure this will generate the language A raised to n, B raised to 2n? Are you sure? Let's try. Can this DFA accept the language of our interest is the question. See, let us give a string of the form A followed by 2 B's. A followed by 2 B's. This is of the form A raised to 1 B square, correct? And it is the part of the language, because n is 1, then number of B's must be 2. Now if you actually scan this string A double B, then it is accepted, because after first A we have B followed by second B, and we are in the final state. So you may say that A double B is accepted. What about 2 A's and 4 B's? Just check 2 A's and 4 B's. We have 2 A's followed by 4 B's. So how do you deal with these 2 A's? First A followed by second A, we are looping here. And after that, how do you deal with this 4 B's? We have 1 B followed by more B's, 3 B's, correct? 3 number of B. And we are in the final state. So this is also accepted. So you may feel that we have successfully constructed a DFA which accepts this language. But listen very carefully. This DFA should reject other strings which are not the part of the language. It's not the only question of acceptance. It's the question of rejection also. What I am saying is, what if we give a string like this? Let's say double A and 3 times B. Now this is not the part of this language, because if there are 2 A's, then there should be 4 B's. Now how do you deal with this first 2 A's? First A followed by second A, we are looping. And then how do you deal with 3 occurrences of B? First B, and then we can loop 2 times. And then we are still in the final state. What that means is this DFA will accept the strings of the form a raised to I, b raised to j. Please try to understand. Please try to understand. So it will also accept the string which has 3 a's and 2 b's. Just check it. All these strings are not the part of L. Some intuition like this, if you try to construct DFA, you will ultimately know that DFA does not have memory. Just check my words. DFA can remember only a few letters that it has just now encountered. But as soon as the loop starts, DFA cannot remember how many A's have passed, because this loop will eat up, or this loop can consume any number of A's. So how do you know by the time you reach B, how do you know how many A's have passed? Because you should have some count of number of A's. Okay, 4 A's have passed, so I should count 8 B's over here. But there is nothing called counter or nothing called memory which can memorize how many A's were there so that we can remember how many B's we should get or we should have. This is a big problem with DFA. So we need a powerful system or powerful machine called PDA, push down automata, which is going to be our next chapter. Not so soon, but push down automata. Push down automata has an additional memory, which we call it as stack. And using this memory, we can remember how many A's have passed, so that now if we start reading B, then we should exactly have double the number of A's as far as tally of B is concerned. Let's look at one more problem that we actually solved using pumping lemma. L is equal to a raised to n, b raised to n, such that n is greater than 1. You know this is also not regular. But what does our intuition say? If you construct a DFA saying that n should be greater than 1, so there should be at least one A. In the beginning, the first letter has to be A, and if the first letter is B, send it to dead state, because the string cannot start with B. Now after this first A, there can be more number of A's. But the problem is how many A's have this DFA actually read? There is no account of it. DFA is not able to remember how many A's. But then what follows is B and some number of B's. Can you be sure that the number of A's that DFA has gone through is exactly equal to number of B's that DFA will go through? And can you call this as final state? Just check. This DFA will even accept A and 4 times B. Just check it. The DFA will be in the final state, but this string is not the part of L. By the way, this DFA will also accept the strings of the form A raised to n, B raised to n. Yes, no doubt, it will accept these strings, but the problem is it will also accept the strings which should be rejected. That's the problem. So when do you say that you are successful in building DFA? You say you are successful in building DFA if the DFA accepts the strings which are element of L, and DFA rejects the strings which are not the element of L. But this does both. This accepts both type of strings, which is wrong. So hence DFA cannot be constructed for this. But I told you this is trial and error. Indeed, trial and error. By the way, if I ask you a very quick question, just you can stop the video and you can use your intuition over here. What if I say a raised to n, let's say a raised to n, b raised to m, c raised to m, d raised to n. This is the language such that n is greater than or equal greater than 1, greater than or equal to 1. Okay, greater than or equal to 1. So what if we want to prove that this is not regular? Not regular. What is your intuition? You say that there has to be at least one A. After that, there should be more number of A's, and the leader must be A. If it is anything like B, C, D as the leader, send it to dead state. You can't have B, C, D or these letters B, C, D in the beginning. So, and then you loop around for any more characters and the machine will stay in the dead state. But after this A, there can be arbitrary number of B's, and then there should be C. Now the problem starts. You see, number of C's must be equal to number of B's. But there is no such source here, because you see number of B's must be equal to number of C's, B raised to m, C raised to m. But there is no way in DFA that DFA can remember how many B's have been read and C's must be matched with that. Same problem will occur with D. Same problem will occur with D also, because number of D's here must match number of A's. But we really have not counted, or there is no source, no method to count how many A's have been encountered so that we can match it with number of D's. That's the problem with DFA, which PDA will surely remove. Well, this video should be taken just as an intuition, so that in GATE or in any other competitive exam, when you are given some language to prove that it is not regular, you can use this intuition and get ready, first of all, to say that yes, the language 99% of the times is not regular. Okay, so that's it. Thank you very much.